Okay, this is Integrated 1 test to review. Part 1 is about skills. So, looking at number 1, it says the ordered pairs 3, -5, 6, -3, 9, -1, 12, 1, and 15, 3 are a function. We write the ordered pairs in a table. What is the rule that represents this function? So the first thing is, let's label our points as x and y. So here's x and y, x, y, x, y, the x and the y coordinate, and for the fifth point, x and y coordinates. If we label everything first, it's easy to see what goes where. So if I look at the first point, 3, -5, I can put that here. 3, -5. The second point is 6, -3. Third point is 9, -1. The fourth point is 12, 1. And the fifth point is 15, 3. Now when it's in a table, I can look for patterns. Because remember, the slope is the change of y over the change of x. So if I can find the change of y, it's what's the pattern. So looking at the y coordinates, let's see how it changes from -5 to -3, -3 to -1. So if I look for that, from -5 to -3, what's that change? Does it go up or down? And it goes up by 2. What's the change from -3 to -1? Up by 2. If I keep looking, it's another +2 and +2. So the change of y is constant. That's good. But I have to look also at the change of x. So if I look over here for the change of x, how is this changing? From 3 to 6, it's +3. And then again, if I look, it's +3. And 9 to 12 is +3. And so is 12 to 15. So I'm looking at this question, when I look at the patterns, my slope is going to be +2, which is our change of y, over then the change of x, which is +3. So my slope in this example is 2/3. But to write an equation or a rule, because I want a rule, I have to be able to find also the starting value or the y-intercept. And that's always going to be in a table where x equals to 0. So if you think about this, can I find the y value when x equals to 0? So looking at my pattern, if the pattern is to add 3 going down the table, if I go backwards in the table, the pattern would be to -3, subtract 3. So 3 minus 3 gives me my 0. Using that same logic, if I look at my y's, if the pattern is to go +2 going down, the pattern to go backwards would be -2. So the question then becomes, what's -5 minus 2 more? -5 minus 2 will give me -7. This is my y-intercept. So with those two quantities, I can now write an equation of my line, or my rule, in slope-intercept form. Y equals my slope, 2/3, x, and then my y-intercept, which I just found here, which is -7, will complete my equation. So for number 1, that's the answer. Okay, number 2, we're asked to graph y equals -2/3 x plus 3. So the first thing here is let's identify what we have in this equation. So if I look at my slope-intercept form, I can see that I have my slope and my intercept given to me in the beginning. So first, let's start with the y-intercept, which is going to be 3. So to plot that point, I go to the y-axis, which is this axis, and I go to the point at y equals to 3, there. I then want to apply my slope. Now my slope, in this case, is going to be -2/3. So if I put it here on the side, -2/3, just to kind of help us identify which way to draw this line, I'm going to put down the verbal description. So -2 means to go down twice, and then +3 means to go right 3 times. So if I apply that, then what I get here from the y-intercept is I'm going to go down twice, okay, and then I'm going to right 1, 2, 3 times, which will give me my second point right there. So again, I went down twice, I went right 3 times to give me my second point. And once I have that, I can then just connect my points to graph my line. Okay, number 3. Determine whether the following relations represent a function and indicate whether they are linear or nonlinear. Justify response in a complete sentence. So the first thing is it a function or not? Really quick, to remind you about functions, a function is defined for every input having one output. So if I look at example B, which has 4 inputs, 0, 1, 2, and 3, they each have their own output. So this is a function. And in fact, if I look at all 3 of them, because example A is in slope-intercept form, that's a function. And if I look at example C, again, every input has one output. So these are all functions. So the question becomes is, which of them are linear and which are nonlinear? So to look at that, if I look at example A, because it's already in slope-intercept form, that this is a form of a linear function that we've used. So that's going to be linear because of its form. If I look at example B, to identify if it's linear or not, I need to have a constant plus or minus pattern in my coordinates. So if I look at the x coordinates, what's the change of x here? So it's plus 1. Between these two it's plus 1. And between these two it's plus 1. So this is good so far. So far I have a constant plus 1 pattern. Plus 1, plus 1, plus 1. But if I check the y coordinates, the change here is plus 1. The change here is plus 3. And the change here is plus 5. Now this is not a constant pattern. This is changing in different amounts. So if it were to be constant, it would be like maybe, for example, plus 3, plus 3, plus 3. But this is not constant. So for this example, this is going to be not linear. Now for the last example, if I look at these 4 points, I prefer to see points in a table, so I'm going to just do this really quick. I'm going to put these 4 points, excuse me, in a table. 1, 3, 2, 1, 3, negative 1, and 4, negative 3. And I'm going to see how these change. Excuse me again. So in this case, from 3 to 1, it's going down by 2. From 1 to negative 1, it goes down by 2. And again, down by 2. So this is a constant pattern so far. So far, this is good. If I go to my x coordinates, these go up by 1, and up by 1. So in this example, as I look at it, both the y change is positive, or constant, sorry, and the x change is constant. So this one is then going to be defined as linear. And that's how that works. Number 4, find the slope of the line. So to do this, I need to find 2 points. 2 points that I can use to identify the rise of a run. So right away, I look at this point here, and I like that one, the point 0, 2. And as I trace along, I'm going to look down, and I like this point here. Those are 2 good points that I can use. Remember, if I were to pick a point like this, that's a bad point because I don't know the exact coordinates for it. I'd be guessing, and that's not good. So once I have my 2 points, I need to just count what's the change of y. So I need to find out how does y change from left to right as I trace this line. So this point here has to actually move down 1, 2, 3 times. So if it's doing that, it's going to move down 1, 2, 3 times. That's a negative 3 because it's going down. And it has to run across 1, 2, 3, 4 times. So in doing that, then to find the slope, it's going to be the change of y, which in this case is negative 3, over the change of x, which in this case we saw was 4. And that's it. That's how you find slope. Okay, number 5. Write the slope-intercept form for the equation of the line. So to do this, I want to have this form. Slope-intercept. Y equals mx plus b. I need to find 2 quantities. What's the slope? And what's the y-intercept? So we'll start with slope. So I want to find first the slope. And like the previous example, number 4, to find slope I need to have 2 points. Now in this case, I already give you 2 points. There's one here, and there's one there. So I need to just count, again, from left to right. Excuse me on that. I need to count the rise and the run. So the change of y is going to be 1, 2, 3, 4, 5, 6. Oh, let's do that again. I hit the screen. So let's try this again. So we're going to go, okay. Again, from this point, we're going to go 1, 2, 3, 4, 5, 6, 7. So I have to go up by 7. That's going to be positive. And I have to run 1, 2 across. So the slope here is going to be 7 over 2. Again, I just went up 7, and I went across 2 to reach this other point. Now that's the easier part. In this case, to find the y-intercept, which is going to be the b term, it's kind of tricky because if you look at my line, I'm looking for a point, basically as I trace my line, I'm going to find where does it cross the y-axis, which is going to be somewhere up here. But the problem is that my grid stops right here. So let's be creative here, and let's actually extend the grid ourselves. So if I do that, I'm going to apply the slope a second time. So if slope is to go up by 7 over 2, let's do that same thing again, because it is a line. So again, if I go up by 7, so 1, 2, 3, 4, 5, 6, 7. So again, I'm going up by 7, so 1, 2, 3, 4, 5, 6, 7. And then I go across 2, which gets me 1, 2. That gives me this point here. This point. Now, that is going to be my y-intercept, because if you extend out the axis, you see how it's going to go out just like that. So I'm going to hit it. But then the question is, what number is that? So if you look over here again, I did go up here 1, 2, 3 times. So the final answer is going to be 1, 2, 3. So it's from 6, 7, 8, 9. So this is going to be a 9. Put this in blue so you can see it better. That's 9. So if I were to draw my line out, it does hit at 9 here, which is my y-intercept. So that means it's going to be, put it in blue here, it's a 9, because it crosses at that point. So with that in mind, then my equation is going to be y equals slope plus 9. Okay, number 6, we're going to graph the line y equals 4x minus 6. So again, just to have the notes in the same question here, let's put the form. And in this case, my y-intercept is going to be negative 6. So to do that, notice how in this grid the ticks go by 2, so be careful with that on the test, and any question actually. So if it's negative 6, I'm going to go down to negative 6 right there. That's my y-intercept. And then I look at my slope. My slope is going to be equal to 4 in this case. So if I put this here on the side, slope is 4, and if it's ever a whole number, it's always over 1. So if I put the directions, it's up 4, then right once. So from your y-intercept, you're going to apply these directions. You're going to try to go up 4, and then right once. But again, be careful, because going up by 4, you have to only go, in this case, 2 ticks, because here's going to be up 2, then 4. And then to go right 1, see how this is 2? So 1 is in here in between. So if I apply that then, what I get is I'm going to go up 4, 2, 4. And then I'm going to run across just once, which is halfway here. So that gives me a second point right there. And in fact, if you want to do it again, just so you see the pattern one more time, it's up 4, so it's going to be up 2, 4, and then right once, which is right there. So we'll put a point there for you. So it's right here. And then I can just draw my line. And there you go. Number 7, solve and graph the following equations, indicate each slope. So in this case, I want to isolate, for example, A, the x variable. So I'm going to just use my algebra skills, and to cancel a positive 7, I'm going to subtract 7 to both sides. That's a 7 there. So I get 3x equals negative 9. And then I'll divide by 3. A little bit messy here, but if I divide this by 3, I'll just do it here, I'll erase it. I get x equals negative 3. So this is my solution to that equation. Now if I just move this out of the way, so it's not way of our graph, x equals negative 3. So again, this is the x-axis here. So where is it negative 3 at? As you trace along, where is it negative 3? And it's right here. So if I put a point here, here's x equals negative 3. And in fact, to graph this line, I want to find out all the points where x is negative 3. So it's going to be represented by a vertical line. Now, if you remember back to slope, to identify the slope of a line that's vertical, to give it a number, it's hard to do. In fact, it's impossible. So we're going to call the slope here undefined. Now in part B, if I solve this for y, I'm going to add 5 to both sides, which leaves me then with negative y equals negative 4. And then I can divide by negative 1 here, so I can just switch both signs, and I'll get a result of y equals to 4. Now, to graph this equation, look at the y-axis. Where does y equal to 4? As you trace along, where is y 4? It's right here. So we'll put a point there. And again, this line describes all the points where y equals to 4. Well, here's where all the points showing y equals to 4. So that's the equation of that line. And remember from slope, when a line is flat or horizontal, the slope is going to be equal to 0. It has no steepness, so we can give that number of 0. Number 8, find the x and y intercept of the line. So to find the x and y intercept, let me write this again on the side. So I'm going to show you both here separately so you can see what we do. So here's the same question twice. So if I want to find the x-intercept, think about this logically. If I'm looking for the x-intercept, using this equation here on the left, using this one, if I want to find the x-intercept, it would make sense that I want to eliminate y. So I want to get rid of this term. I want to set y equal to 0. So if I do that in the very beginning, it's like doing this. I just make it go away. So if I'm looking for x, I'm going to get rid of the y-intercept. And then I'm going to solve the resulting equation. So in this case, if I'm going to solve this equation, all I have left is 3x equals to negative 30. So I can solve that by dividing by 3 and find that the x-intercept equals to negative 10. Okay, now if I look at the second equation that I have, I'm going to use this to find the y-intercept. Now to find the y-intercept, I'm going to let x equal to 0, which in effect means that I can just get rid of the x term like that. I can cover it. And I can solve the resulting equation. So here, negative 6y equals 30. I can divide by negative 6 to both sides, which gives me y-intercept equals, now remember, a negative 30 divided by a negative 6, say that to yourself in your head, a negative divided by negative equals a positive 5. Those are your intercepts. Number 9, find the x-intercept and y-intercept of the line graphed below. So to find intercepts from a graph, it's pretty easy if the line crosses the axis at exact points. So if you look here, if I want to find first the x-intercept, I'm going to trace my x-axis, and I'm going to look around, where does my line touch the x-axis? And I'm getting closer, and it hits it right here. So to find the x-intercept from a graph, it's just at what point is your line touching the x-axis. And in this case, that's going to be at 4. Now to find the y-intercept, again, if you trace your line, just kind of look around. When does it touch the y-axis? Which is going to be right here at this point. So that's going to be at negative 2. So I give that a little point here. This will be your y-intercept. I'll write it down here so you see it. And that's going to be at negative 2. So that's how that one works. That one should be pretty easy as long as the graph touches at exact points. Okay, number 10, a line passes through the points 3, negative 4, and negative 1, 8. Part A, find the slope. So to find the slope, remember that slope is just the change of y over the change of x. So I'm going to take these points here. I'm going to put them in a little table. So 3, negative 4, and negative 1, 8. And I want to find the change of y and the change of x. So the change of y is going to be on this column. So how do I change from negative 4 to 8? So I'm going to be increasing, so I'm going to be going up by 12. And if I look at then the x-axis, how do I change from 3 to negative 1? From 3 to negative 1, I'm going down, or I'm going more negative. So that's going to be going down by 4, goes down by 4, so it's negative 4. Once I find the change of y and the change of x, I can find slope to be that. So the change of y, which we found to be 12, over the change of x, which is negative 4. And if I simplify that, I get negative 3. So my slope here is negative 3. Now using this in part A, I'm going to then part B write an equation in point slope form. Point slope form, to remind you of what that is y minus y sub 1 equals m x minus x sub 1. And I need to find two different things. I need to have a point, and I need to have a slope. So I just found the slope to be negative 3. So in writing this new equation, I can put that here. That's negative 3. But what I got to do is I got to pick a point. Now in this question, I'm going to go ahead and just pick the point 3, negative 4. I'm going to use that point. So I'm going to put it here down on the side, 3, negative 4. And if I label that point with its coordinates, this is the x and this is the y. So if I go to this, it's actually x sub 1, y sub 1. So when I go to the form, and my point is labeled like this, then when I try to plug things in, it's easier, because if I ask you, what's your x sub 1, what number is that going to be in this question? I already have it identified here as 3. So I'm going to put this as 3. And then when I ask you, what is your y sub 1 in the formula, I'm going to look at my point, and I have it labeled here already as negative 4, so I'll put that in there also. This is negative 4. Now what's tricky with this form is you have to be careful with your minus signs, because this negative here is part of the formula. This negative 4 came from my actual coordinate. So I'm going to have the double negative here. So I'm going to have y minus negative 4 equals the slope, which is negative 3, x minus 3. And the last thing I'll do here is to simplify this to make it look cleaner. I'm going to take care of this double negative here and make it into a positive. So what I get is, and I'll put it in blue to make it look different, y plus 4 equals negative 3, x minus 3. That's point slope form. Now moving right along to slope-intercept, if I take my point slope form and I distribute this negative 3 and move this 4, I can solve my way to slope-intercept. Slope-intercept, to remind you, is going to be just where I have y equals mx plus b. So I get y by itself. So in this case, if I write my slope-intercept again, my point slope from above, and I'll keep it in blue so you can see where it's coming from, and I solve this for y, my first step will be to distribute this negative 3 into both of those. So negative 3 times x is negative 3x. And again, notice how I'm saying it to myself, because now I'm going to say negative 3 times negative 3. So again, a negative times a negative will be a positive 9. I've yet to use this, so I'm going to write it again the same way I see it. Y plus 4 equals. My last bit now is to take this plus 4 and move it to the right. So the opposite of plus 4 will be minus 4. And I'll put it to both sides, so this cancels. And my result is going to be, I'll put it over here, y equals negative 3x. And then what I got to do here is combine these two together, so 9 minus 4 will give me my 5 plus 5. This is slope-intercept form. Lastly, in this question, I want to go into standard form, which would be basically where you put x and y together on the same side. So if I look at this form here, y and x are on opposite sides of the equal sign. So I got to get this negative 3x over to the left. So how would I do that? Let me write the equation again. So right now I have y equals negative 3x plus 5. And I want to get this negative 3x to the left side. So I need to cancel it. So to cancel negative 3x, I'm going to just add 3x to both sides. So this goes away. And we get 3x plus y equals 5. This is standard form. And just to kind of be clear as to what is what, if I look here, the a value is going to be 3, b is 1, and the c is 5. Okay, moving along, number 11. Write the equation of the line. So in this case, these are special cases of lines that are either horizontal or vertical. Now we know that for a line that's horizontal it has a slope of 0, and for a line that's vertical it has a slope of undefined. That's undefined. So to write the equation, basically if I look at this line, where does this line cross the y-axis? It crosses it here at -2. So this line actually represents y equals to -2. And that's kind of it. That's how you do this one. So when the line is flat, or it has a 0 slope, just identify where it's crossing the y-axis, and that's the response. Y equals -2. Now to write the equation of this graph, notice how this only touches the x-axis. It touches it right here, which is x equals to 3. So that itself is the equation for this vertical line. So when you have these special cases, just identify where your line touches the axis, and that point itself is the equation. So again, here it only hits the y-axis at -2, so y equals -2. There's your equation. Again, this line only hits the x-axis at 3, so that's your equation. Number 12, give the graph below. So this is an inequality. I have to make some choices here. First, I need to identify what's the y-intercept and what's the slope. So this is kind of a messy question. It's hard to see, but if I look for my y-intercept, as I trace my line, where does my line hit the y-axis? And it hits it right here. So this is the y-intercept. It's going to be at 2. So that's my b value. So my y-intercept is at -2. Now, if I want to find the slope, I have to pick a second point that I can use to be able to count my slope. So if I look around the line, where is there a good second point? And I think this here is a good point, the point 1, 3. So I'm going to mark it also. So with those 2 points, I can count my slope. And again, remember, it's always from left to right. So as I count from this point to this point, I have to count up 1, 2, 3, 4, 5 times, and then I run once. So again, I count up 1, 2, 3, 4, 5 times, positive, and I run once. So my slope will be 5/1, which we'll just call 5. So these are 2 important values to have for this problem. Now what I got to decide, because it is an inequality, is the line here solid or dashed? And from what I can see, hopefully I'm right on this, it's kind of not a good copy, this line here looks solid to me. So when the line is solid, my inequality is going to have the underscore. The last thing I need to decide is, am I shading this above or below the line? So if you look at this line, if I look at the y-axis, do you see how y gets smaller going down? So this graph actually is shading this down. And so using this line as my boundary line, this is actually shading in the downward direction. It'll be going this way. So because it's shading down, I'm going to have a less than symbol. Oops, let me use the actual pen. A less than symbol. And again, because it's a solid line, I'm going to include the underscore. So my final response will be y is less than or equal to my slope, which we saw over here was 5, x, and then my y-intercept. So this is the inequality that represents this graph. Now having this written out, part B says, is 2, 1 a solution to this inequality? So I can do it 2 ways. I can either use the graph and just plot the point and see where it lands. If it's in the shaded part, anything in this shaded part is a solution. In fact, because this line is solid, the line also counts. If it happens to fall where it's not shaded, this would not be a solution. So let's take that first. If I take this point 2, 1 and I apply it, 2, 1 is going to be right here. Is that point in the shaded area? Yes, it is. So this point would be a solution, because it happens to fall in the shaded portion of this graph. Now the other way to do this, and I'm going to do it right up here in this spot, is I could actually just take this point, which is an xy, and I can plug it into my inequality. So I can take the x here and plug it into this x, and take the y, put it into this y. So I'll do it here on the side so you can see it. So I'll write it again. Y less than or equal to 5x minus 2. But we now know that y, if you look at the point that's labeled, y is 1. So I'm going to have 1 less than or equal to 5 times, and then x here we said was 2. So we'll put that in here in its place. And I can work this out. So when I work this out, 5 times 2 here is 10 minus 2. And then 10 minus 2 is 8. So the question becomes, is this true or not? Does this read true? So if you look at this, this is less. Oh, my E's not very good there. This is more. So is 1 less than 8? And that's true. So whenever you check algebraically, if the result is true, you say it's a solution. If this were to be read false, you say it's not a solution. Okay, number 13. Halfway there, guys, pretty much. Multiple response. So just to be clear, when you have a multiple response question, what it's saying is you have a lot of choices, and you have to check all of them individually and circle all of the ones that apply. So you can have more than one answer. Okay, so check each of them by themselves. So if I do this, the question here says, identify all the linear functions that have a slope of 2/3. So I want to have that value of 2/3. So I'll go one at a time. If I look at example A, I want to identify the slope. Now the slope here is going to be right here. Okay, this is a trick question because you see a 2/3 in the problem, but this 2/3 is the y-intercept. It's not the slope. The slope is going to be the multiplier here, the coefficient of x. So slope here equals to 4. So will this have a slope of 2/3? No, it does not. So that one is no good. If I go to B, B gives you a slope of 8/12. So it's just a slope, nothing else. So let's simplify that slope down. So 8/12, I can reduce this by 4. If I do that, 8 divided by 4, so if I do it divided by 4, I get 2. And then 12 divided by 4 is 3. So does this match my prompt? Is it 2/3? Yes. So this is going to be a good response. We'll put it in green. So B is a good choice. If I go to the example C, just finding slope from a graph, we need to find some points here. So I'm going to find here, I'm going to use this point, and as I look around, I trace the line, I see that I have this point here. That's a good point. So I'm going to find slope. We're from left to right. In this case, I'm going to rise 1, 2, 3. I missed one there, so let me do it again with my pointer. So we go up 1, 2, 3. So it goes up 3, and then I have to run across 1, 2, 3, 4. So slope here is going to be 3/4. Does that match my prompt of 2/3? It does not. They're not the same, so this does not work. When I go to my table example, which is a D, again from a table I can find slope using the patterns or the change. So let's first start with the Y column. So how does it change from 5 to 7? From 5 to 7 it's going to be adding 2, so it goes up 2. And again from 7 to 9 it's up 2. If I get the X column, which is going to be these points here, how do they change? So from -4 to -1, how is that changing? And if you're not sure what I'm doing with this one, just to be clear, think about a number line. If I'm at 0 here, and I have -1, -2, -3, -4, when I say how is it changing, what I mean is from -4 to -1, so from -4 to -1, what's the change? And the change is that I'm going to be actually going up by 1, 2, 3. So I have to go to the right 3 times to get to -1. So here it's +3. And again here it's +3. So in example D, if I find my slope will be the change of y, which is 2, over the change of x, which is 3. Does this match my prompt, 2/3 and 2/3? And it does. So using green again, this is a good choice. Now if I look at example E, there's a lot of examples. I need to take this. Now example E, this is in standard form. And in this form, I can't see the slope directly. So I'm going to have to rearrange this and solve it for y. So to do that, let's first move this x term using negative 2x. Okay, that's a 2 there. Negative 2x. This cancels out, so I get minus 3y equals negative 2x minus 3. Then I divide by negative 3. Divide by negative 3 to all the terms here. So what comes out here when I do this simplification is I get y equals, and notice how, again, if I say this to myself, look at the slope here, negative 2 divided by negative 3, a negative divided by negative is a positive, so I end up with a 2/3 x, and then if I look at this last part here, negative 3 divided by negative 3, again, a negative divided by negative is a positive, so I get plus 1. So in this equation, my slope here is going to be 2/3. Does this match my prompt in the question? And again, it does. So this is a good choice. I'm getting kind of messy here on you guys. But if I look at choice F, this one's a little bit faster. Just identify the slope. So this is point slope form. And in this form here, point slope, slope is going to be right here. So if I circle it in different colors, so it's not all just red. Slope here is, you can just see it from at face value, it's 2/3. Does that match what they asked me for? 2/3? And it does. So this one's also good. So far we have 4 good answers to this question. Now the last one here, let me move a little bit here on the screen. It says, Mr. Cabrera or Mr. Salazar, we both love to grade tests. It says we can grade 20 tests every half hour. So we can grade 20 tests every half hour. So let's write this as a fraction. So 20 tests every half hour. Now half an hour, if I put it in terms of minutes, how many minutes are in a half an hour? So that's going to be 30 minutes. So I can put this over 30 like that. So this is a slope here. And if I reduce this down, I can cancel, the divide by 10. So this just becomes 2/3. And again, for a 5th time in this question, I have another slope that matches the prompt, which is 2/3. So this also works. So this example has 5 good choices that all have the same slope of 2/3. B, D, E, F, and G.